Hello, as you know, I'm Kainton the Genius, and today we are going to be discussing these topics I've listed here. All of them actually are encompassed into flow networks, but I actually want to show you that the objective is to be able to solve problems like bipartite matching problems. So we are going to start with defining the problem we want to solve, and then we discuss the concept of flow network, how to solve it. We now discuss make a very clear Ford-Fulkerson algorithm, and then we also discuss this concept. It's going to be easy, so just follow along. I'm not going to assume you have any knowledge. All right. Just to remind you to subscribe so that you encourage me to make more videos for you. So click on subscribe button below to subscribe to my channel. So let's get started, and this will be super easy to understand. All right. Let's start with the problem we want to solve. First, you need to understand what a bipartite graph is. A bipartite graph is an undirected graph, GVE, whose vertices can be partitioned into V equal to X union Y, with the property that every edge E belongs to the edge and has one end in X and the other end in Y. Let me take my writing pen so that I could make it a little clearer for you. So let's look at this graph. So we have GVE. Of course, you know that V is a set of vertices. VE is a set of all the vertices, set of all nodes, and nodes is the same as vertices, don't forget. And E is a set of all the edges. Alright, so now we have that is undirected. Undirected means the arrows are not pointing to anywhere. So if you have something like this, a graph having arrow ends, it means it's directed. But for it to be a bipartite graph, it has to be undirected. Keep that in mind. Then we have that is partitioned, the vertices are divided into X and Y. So this is the set of X and this is the set of Y. So two partitions, right? And every edge, all the edges or all the vertices, every edge, the lines, has one end in X and one end in Y. So we can't have something like this in a bipartite graph, right? Okay, so that is clear. I want you to understand it because this concept is what we are going to use to continue discussing other concepts in flow network. So this is a bipartite graph. So each edge must have one end in X in this side, in the set of X, and the other end in Y. So think of it that X is equal to X1, X2, X3, X4, and X5. It's important you understand these notations because that will make it clear in case you are reading a textbook or you are taking a class. Alright, let's continue. Now, what is a matching? That is another concept. Now you know what a bipartite graph is. A matching in the graph, of course, this is a bipartite graph, is a set of edges M with the property that each node appears in at most one edge in M. So what we have here is a matching. So it's a set of edges. So all these edges constitute a match. So if we have edges like this, it's called matching, right? Good. All right. So of course, if we just take 1, 2, 3 edges, this is also a matching, right? Good. So let's move to the next item. Then a set of edges in M is a perfect matching. Is if every node appears exactly in one edge of M. So let me explain the concept of perfect matching. because this is also important. So if you have something like this, let's just assume we have a bipartite graph like this. We have this and we have this. So we have every node appear in exactly one edge in M. So these are what is called a perfect matching. It's also the same like this. Let me draw it for you. This is also a perfect matching. Let's proceed to the next part. The bipartite matching problem, because that is the problem we want to solve using flow network. The problem is to determine the largest matching in a bipartite graph. If we go back to previous, we have this matching, a set of edges. We have that we can actually add additional matching. Remember, matching is simply set of edges, so we can actually add additional matching, like say this to this, x4 to y5, and so on and so forth. So we have, this is not a maximum, the matches are not complete in a sense. So what we are saying is we have to create a matching with a bipartite graph with the largest matching. So how do we do this? We have to formulate a general class of problem, and that brings us to flow network problem, right? So that includes bipartite matching problem as a special case. So to solve bipartite matching problem, we need flow network problem, and that means we need to understand flow network. So we need to develop an algorithm for a general problem, the maximum flow problem. Don't worry about this. That is what we are going to discuss in the next presentation and show how this provides an efficient algorithm for bipartite matching. So if we are going to solve the bipartite matching problem, it means that we first need to understand the flow, maximum flow problem, and of course flow network problem. And then we have bipartite matching as a subset of the maximum flow problem. So the next thing we are going to do is to review flow network. I'm going to stop here and we continue in the next video. I would like to remind you to subscribe.